Alright, so let's try to recreate his square root of 2 is irrational proof. Root 2 is irrational. Okay.
So for
what
this
would you
one,
like to do here?
He used actual squares. And then you had two smaller squares, and then you put them inside the big square like this.
Okay.
So these really shouldn't equal each other. So you had these squares were actually smaller, and then this square was a bit larger. So these squares were a tiny bit bigger, like this.
Okay, so what's going on here?
So then you can do it again. So
it's the same infinite descent problem.
Alright, well, yeah, tell me what the problem is now, just that currently exists in this picture.
well, then you have the same problem. It's that there's another way to do it. Before it was supposed to be the lowest terms, but now it's not.
Okay, so what's the new way? Now that you've taken your 2 squares here, this one plus this one, and we assume they were the same area as this one, the big one. So what have you produced now?
So you produced these 2 squares were the smaller squares, and this square is the big square.
Okay, and we have...
You can sort of do something like this.
Okay.
And you have 2 smaller squares and a big square.
Alright.
And you can do it again. And
And
then
it keeps going down and down. You always find smaller pairs
Okay.
when you said you couldn't.
Alright, cool. Do you remember how he did it with the triangles? Do you think you can recreate that? What did he do with the triangles?
So I think he did this kind of the same thing he did with root 3, but he just left one out. We just got a triangle. You put 2 triangles on the corners, and then you fold them in. So you kind of do it like this.
Okay.
And then he did it a slightly different way than I'm gonna do it. But he said that you can just move this down and you can get another pair like we had before.
Okay.
But I'm going to divide this into 2 equilateral triangles
Alright.
so that we have now another 2 smaller equilateral triangles equals the bigger.
Okay, and where is this triangle?
This is here.
Okay. Alright, so why does this area here have to equal that area?
Because that's how you would get 2 triangles to equal a third triangle. This is the overlap between your 2 original triangles.
Okay. And those 2 original triangles had to, we assumed, summed up to the whole area of the square. So that means this bit wasn't touched. This part was touched twice.
Yeah.
So the part that was touched twice has to add up to the untouched part, and that's what you get here. So you get 2 smaller triangles. Okay, so pretty cool, right?
Mm-hmm.
Alright, so let's go on to his puzzle at the end.